Welcome to the Retro Workbench. You've probably played the viral word game Wordle before. If you haven't, it's pretty simple. The goal is to guess a 5-letter word. If you get a letter in the right place, it turns green. If you get a letter right but in the wrong place, it turns yellow. You have to guess the word in 6 tries. The word changes every day. This made Wordle a viral hit since everyone was trying to guess the same word, turning a solitary word game into a shared experience. A while back, I wrote my own version of Wordle in Python. I called it Wordle, with the CL standing for command line. Now, Wordle isn't a true command line app in the traditional sense. A command line app is simply a command you can run that takes in parameters and either produces output, such as text on the screen or a file, or does something in the background like change a system setting. Wordle is a game that runs in the terminal. It takes no input and produces no output. All interaction is done within Wordle itself. So you could say that my version is not a command line app at all, but a text user interface app. And that's true, but it's still launched from a command line. And more importantly, how would you pronounce this? Let me know in the comments. One of my favorite YouTubers, Kari, made a video where she converts classic games written in BASIC to Python so they can run on modern computers. I'll link her video in the description. I want to do the same thing, but in reverse. Take my Python code and convert it to BASIC so it can run on the Commodore 64. Now, Commodore BASIC isn't the only language I could use to program the game. There were enhanced versions of BASIC, such as Super Expander 64 and Simon's BASIC, released on cartridges for the C64. These add lots of commands to BASIC that make it easier to work with graphics, sound, disks, joysticks, light pins, and paddles, as well as making debugging easier. I could also program the game in assembly language. Assembly language is kind of like a human-readable version of the binary code that the computer actually runs. This would give the best performance because we wouldn't need to run our code through the BASIC interpreter. And of course, there are modern tools available like CC65, a C compiler that targets 6502-based computers like the Commodore 64, and Prog8, a high-level language similar to Python that compiles to 6502 machine code. But I want to keep this authentic to how most average users wrote code in the 80s, so I'm going to stick with BASIC. Unfortunately, this does mean that the game will be slow, but maybe in a future video I'll write a faster version in assembly. There are a few different things this program will have to do. First, it will have to choose a word for the player to guess. Then it will have to ask the player to guess a word and store the guess in memory. Then it will have to compare the guess to the word of the day. If they match, the player wins. Otherwise, the program will check each letter to see if there are any in the right place and if there are any matches in the wrong place. Then it will have to rewrite the guess with the right place matches green and the wrong place matches yellow. Then it will have to count how many times the player has guessed. If they've guessed 6 times already, it's game over. Otherwise, they get to guess again, and the program has to do that all over. Now, because of the limitations of the Commodore 64, I'm going to have to do things a little differently from how I did it in Python. In the Python version, the words are stored in a list. BASIC uses arrays instead of lists. Lists and arrays are both data structures that can hold multiple values, but lists can hold values of different types, while arrays can only hold values of the same type. You might think I could store the words in an array, but here's the problem. The Commodore 64 has, 64 kilobytes of RAM. Only 38 kilobytes of that is available to the user. The original Wordle has 2 word lists, a list of daily words and a list of allowed guesses. Together, these lists take up 101 kilobytes. Obviously, that won't fit in the memory of the C64. So instead, I'm going to store the words in a binary file on a disk. But that introduces another challenge. In the original Wordle and in my Python version, every time the player guesses a word, the program compares it to the list of answers and the list of allowed guesses. If the guess isn't in either list, the guess is invalid. Now, to do that on the C64, the program would have to access the disk after every guess. But Commodore disk drives are notoriously slow. So instead, I'm just going to let the player guess any 5-letter string. And then there's the problem of how the program chooses a word. The original Wordle and my Python version choose a word by looking at the current date and counting the number of days since June 19th, 2021, the day the original Wordle launched, then using that number as an index to choose a word from the list of answers. The Commodore 64 doesn't have a real-time clock, so it doesn't know the current date. I could ask the player what the current date is, but Commodore Basic doesn't have a date function, so while it would be possible to calculate the number of days, it wouldn't be straightforward. So instead, I'm going to randomly choose a word. Of course, that means if you play more than once a day, you'll get a different word every time, unlike the original Wordle. Okay, we just went over a lot of technical details, and I might have to explain even more as we go, but let's go ahead and take a look at Wordle. So here's Wordle. When you start it up, you get the same tutorial message as the original Wordle. Now, you can see here I used a red letter instead of a gray letter because in the terminal it's a little bit harder to see the gray compared to the white letters. But other than that, this is the same intro as the original Wordle, so let's go ahead and try to solve it. I can make this a little bit bigger. Now, I heard somewhere that the best starting word for Wordle was later, so let's try that. Okay, so the only letter we got right is an E, and it's in the wrong place. Okay, let's try this. Okay. Let's try house. How about this? Okay, that was right. So that's how Wordle works. It's just like Wordle. Now let's take a look at the code. Okay, here's the Python code for Wordle. Now before I start writing the basic code, I want to make a few changes that will make things a little easier. First, let's get rid of everything related to hard mode. This game is already going to be pretty challenging to write in BASIC, and we don't need the extra complexity of hard mode. Right here I have a Boolean called hard that is set by the keyboard input. If it's the letter H, hard is set to true and hard mode activates. If it's anything else, hard is set to false. Since we're getting rid of hard mode, I can remove that Boolean, but I still want the player to be able to see the intro and press enter to begin, so I'll just put an input function here and not set it to a variable. The keyboard display is nice, but it's unnecessary since you can see all of your guesses, so I'll take that out. Now, since Commodore Basic doesn't have a date function, we're going to take out the date comparison and just choose a random word. I happen to know that there are 2,315 answers, and lists start at 0, so we'll need to choose a random number between 0 and 2,314. We need to remove this part that checks to see if the guess is a valid word. The Commodore 64's display is limited to 40 columns of text and 25 rows. This intro is 60 columns by 28 rows, so we're going to cut a few things out. There, now the intro fits in a 40 by 25 grid. Now let's organize this code a little bit more like a BASIC program. We've got the main function at the bottom of the program, but in BASIC this code would normally be near the top. So we're going to move this up. The intro is stored as a string, but in BASIC this will need to be individual print commands. So I'll go ahead and move the intro into main. I've got the actual gameplay in a while loop, but the only loop in BASIC is a for loop, so I'll change this to a for loop. And since we're using a for loop, we can no longer use a boolean as a condition, so instead of setting guess to true here, I'll just break out of the loop. But we actually need the guess variable in BASIC. You'll see why later. Okay, now we have the Python code cleaned up and we can start coding in BASIC. These days, it's easier to develop on an emulator like Vice, but I'm going to type this code in on a real Commodore 64 like they did in the 80s. Of course, I will be using a couple of modern conveniences. I'll be using this USB capture device to record the screen, and this Pi 1541 disk drive emulator instead of a disk drive. This is just a Raspberry Pi Zero with an extra PCB on top that connects to the C64, so I can use disk images instead of real disks. Okay, I've got everything set up, so let's get started. Okay, we'll start by clearing the screen with this character code. And then we'll poke this memory location so the intro can have lowercase characters. This character code changes the text color to white, and I'll have another one at the end of the line to change it back to light blue. I'll use more character codes along the way to change the colors to green, yellow, and gray. Now I'll get a character from the keyboard. We want the player to press return to start the game. If they press anything else, we'll just go back to line 280 and watch for them to press another key. Now we want to choose a word. We'll choose a random number between 1 and 2315, and that will be the index of the word. Now we'll clear the screen again and switch back to uppercase only. We'll need to make an array to store all the guesses, a value to determine if the word has been guessed, and arrays for the locations of green and yellow letters and how many times each letter occurs in a word. And finally, we're going to make the main game loop. I'm going to run the loop 7 times instead of 6 because after the 6th guess, I want to print the word one last time with the colors. Speaking of printing the guesses, let's do that. We have 6 guesses, and we need to check each guess to see if there is actually a word there. If there is, we want to print it, and for that, we'll need to use a subroutine. Subroutines in BASIC are small sections of code that can be called from other sections. They're kind of like functions in Python, except they don't take parameters, and aren't self-contained. So if you're not careful, they can change a variable you need for something else. Basic lets you type lines out of order, so we can go ahead and type in this subroutine right now. If the word has been guessed, we can end the game here. If the player has already guessed 6 times and didn't get it right, we want to print the word to the screen. I want to make it look nice, so we'll need to use another subroutine. And of course, we need the guess to be exactly 5 letters. So we'll check the length of the guess. And if it's not 5 letters, we'll just ask for a guess again. We'll be using subroutines again to check for green and yellow letters. And since subroutines aren't self-contained, we'll need to reset our arrays. Now we want to count how many times each letter occurs in the word. Mid gets a subset of a string, in this case a single character. Ask gives the ASCII value of a character. The ASCII value of A is 65, B is 66, and so on. So we want to subtract 65 from the ASCII value so we can use the number as an index. And now we'll look for all the green letters. This part is pretty similar to the last part. We'll have another subroutine here. Now that we know which letters are green, we can see if the word has been guessed. If it is, we don't have to check for yellow letters and we can just end the game. So what I'll do first is say that the word has been guessed. But if any letters are not green, we can then change the variable to say it's not guessed. And now we can check for yellow letters. There's another subroutine here. Finally, we'll save the guess in the array with the colors applied. We'll be using character codes to change the color of the letters. If a letter is green, we'll use character code 30. And if a letter is yellow, we'll use character code 158. Okay, now that we've got the whole program typed in, let's go ahead and save it to the disk. I just looked over my code and I found a few mistakes, so I went ahead and fixed those. And I don't know about you, but I'm glad we're done with coding. Let's play Wordle. Okay, let's try our starting word later again, since apparently that's a good starting word. Okay, looks like we've got an E and an A. Okay, let's do this and see if we can find where that E is. It's not there. Let's try this. It's not the beginning either. How about this? Okay, we found the E, and now we know that there's an A and a B in the word also. How about this? No, that's not right. Okay, the word was kebab. Well, that's Wordle. So it works just like Wordle. If you know anything about Commodore's 8-bit line of computers, you know that there is some compatibility across the different platforms, though it's not 100%. I only have a Commodore 64, but I did test my code in emulators for the other models. The Commodore 128 doesn't display the intro properly because it uses a different memory location to switch between uppercase and lowercase. But the game itself works fine. I got the same result on the Commodore Plus 4. The C128 in C64 mode works perfectly. The VIC-20 technically runs the code, but it's not really playable. The Super Pet and the CBM2 do not run the code at all. Now, just to be clear, I'm not claiming that this is the best way to make Wordle for the Commodore 64. In fact, it's not even the best version that exists on the C64. The YouTuber Not a Wizard has an even better version that looks much nicer and has animations. I'll link to his video in the description. I just wanted to show a version of Wordle that an average coder could have made in the 80s without the modern tools we have today. Well, that's going to do it for this video. If you enjoyed it, I'd really appreciate it if you gave it a like. And if you want to see more videos like this, why not go ahead and subscribe? Have you ever used a Commodore 64? Whether it was for coding, gaming, music production, or anything else, I'd love to hear about it in the comments. And if you want to try Wordle yourself, either the Python version or the Commodore 64 version, you can find them both on GitHub. The link is in the description. I've got lots more projects like this coming up, so if you want to see previews of my projects, follow me on your social media platform of choice. Thanks for watching, and I hope you'll join me again on the Retro Workbench.